Steady state approximation. One reaction 2NO plus O2 gives rise to 2NO2 gas. This is called oxidation of nitrogen oxide to nitrogen dioxide with following proposed mechanism. This is the first step, fast and reversible. Its rate constant is K1 for forward reaction, rate constant K minus for backward reaction. Second step, NO3. This is the intermediate formed, react with the NO and convert into 2NO2 gas. Slow reaction, rate determining step. Rate determining step is a generally slow step. So in this reaction, the formation of NO2 is given by the second step. Always rate law will be given on the based on the slow step. So this is a slow step. So this is a formed NO2. It is given by rate of NO2 production is equal to K2 NO3 concentration and NO concentration. Keep in mind, generally in rate law, intermediate should not appear. In rate law, intermediate should not appear. Therefore, we have to remove this NO3 from the rate law. How to remove this? I will explain. Here given one mechanism is NO convert into NO3 first step with the oxygen. It is fast and reversible. NO3 plus NO convert to NO2, that is a slow and rate determining step. So based on this, we can write the rate law. So rate of formation of NO3 is equal to 0. Reason, it is formed in the first step and consumed in the backward reaction, also consumed in the second step. Totally its formation is 0, mean concentration of NO3 is constant. In first forward step is consumed, in backward forward reaction is formed, backward reaction is consumed, and in the second step it is consumed. Therefore, it can be represented as K1 K1 NO concentration, O2 concentration, rate of formation of NO3 with respect to forward reaction. That's why it is positive rate formation. Next, in backward reaction, it is consumed, therefore minus rate decrease with the reactant, because that time backward reaction NO3 reactant. Therefore, it is represent K minus 1 and NO3 concentration, and in the second step also it is consumed, again it is minus K2 NO3 concentration, NO concentration. Steady state approximation, meaning with respect to intermediate, its net rate formation always 0, because in the first step forward and backward step it is consumed, in the second step also consumed. Therefore, its concentration constant and net rate formation is 0. That is called steady state approximation. Now, already we know that rate law is represented as a K2 NO3 concentration and NO concentration. NO3 is intermediate, this should not present in the rate law, therefore we have to remove it. How to remove it means from this equation we have to separate the NO3 term. Now I am separating the NO3 term. So this part I will take left side. Therefore, the minus term is going to plus term. K minus 1 NO3 concentration, and another also this one term I am taking left side, that is going to plus K2NO3 concentration, NO concentration is equal to this one term, that is called K1NO concentration, O2 concentration. Now these both are having NO3 common, that's why we take NO3 common. So NO3 concentration multiply with the K minus 1 plus K2 NO concentration is equal to K1 NO concentration, O2 concentration. Now we know that NO3 we have to separate it, means NO3 concentration is equal to K1 NO concentration and O2 concentration divided by K minus 1 plus K2 NO concentration. Now we separated the intermediate from the steady state approximation rule. Now we can place into this equation. What is the previous equation? K1NO O2 concentration, NO concentration. According to the equation, rate is equal to K2 NO3 concentration, NO concentration. R is equal to K2 only. NO3 concentration we got from the previous equation is K1 NO concentration, O2 concentration, denominator K minus 1 plus K K2 and this is. Now keep in mind the first step, step 1 is fast, step 2 is slow. Therefore K1 and K minus 1 value is high. Higher the rate of reaction, higher the K value. And K2 value is low. Compare with the K1 and K minus 1, because that is a fast reaction, forward backward reaction, equal rate. So K2 value or the K2NO value is lower than K minus 1. Therefore, we can neglect this term. Then after neglecting, then we will get here R is equal to K2, K1, NO concentration, O2 concentration divided by what you are getting, K minus 1, and that neglected term neglected. So now all this overall I am writing, that is called overall rate constant. R is equal to K overall rate constant NO concentration into O2 concentration. This is a final rate law by using steady state approximation method. So totally keep in mind what is the steady state approximation method mean. Intermediate concentration is constant. Reason it is formed in the first step and also consumed in the reverse step and also consumed in the next step. Total formation will be 0. Therefore, net rate of intermediate is 0. So what is the use of this steady state approximation? Meaning when any one of the step is not as a slow step, that time we can utilize the steady state approximation method, because the steady state approximation is based on which one intermediate rate is 0 respective. that time it is useful. So keep in mind what is the steady state approximation. When there is no slow step in the reaction mechanism, then we have to follow the steady state approximation method.